Hello everyone, welcome to this video. In this video, we shall be looking at some questions based on sequences. So here, the first question tells us that we have to write the first three terms in each of the following sequence where we are given the nth term. So here you see in the first part, the nth term an is given by an is equal to 2n plus 5. So all of you know how we may obtain different terms. We need to write the first three terms in the sequence. So that means we need to write the term for n is equal to 1, then for n is equal to 2, and then for n is equal to 3. So what is the term corresponding to n is equal to 1? We have a1. So that means whenever how can we obtain a1? In this general term. So this is the general term that is given to us. So an is the general term, right? And this is given to us. In this general term, the places where n is appearing, we need to write n is equal to 1 here. So a1 would be 2 multiplied by 1 plus 5. In place of n, we now have to write 1 for the first term, right? So now you can use BODMAS and simplify this expression. So it is 2 into 1 is 2 plus 5, which is 7. So our first term is 7. Now corresponding to n is equal to 2, we have to write the second term, and you know how to represent the second term. It is a2, right? So how is a2 obtained? When in this expression, in place of n, we write n is equal to 2. So when you substitute n is equal to 2 here, you would have 2 into 2 plus 5. So using BODMAS, you can simplify and solve this expression. So you have 2 into 2, which is 4, plus 5. So the answer is 9. The next term of this sequence, let's see what is it this. So here the next term is a3 with n is equal to 3, right? So for a3, in the general term, in place of n, we will be writing n is equal to 3. So what do we have here? We have 2 into 3 plus 5. So our answer is, firstly we'll multiply 2 into 3, that is 6 plus 5. So our answer is 11. So hence we may write that the first three terms of our sequence, they are 7, 9, 11. Similarly, we can do for the next part. For the next part here, we have an is equal to n minus 3 upon 4 as the general term. So this is the general term, or you can say this to be the nth term, right? So for this nth term here, we can have n is equal to 1 for an. So an would be, in place of n, we'll be writing 1. So we would be having 1 minus 3 upon 4. So you can simplify this to have minus 2 upon 4, which in the lowest form give you minus 1 upon 2. Similarly, when n is equal to 2, you can calculate your second term. Here it is not an, here it is a1. Right? For the first term, we have a1. For a2, in place of n, we have to write n is equal to 2. So it would be 2 minus 3 upon 4. So 2 minus 3 is minus 1 divided by 4. So this is your second term. And for the last term here, we require to calculate for n is equal to 3, we require a3, right? So when we substitute 3 here, in place of n, you would have 3 minus 3 divided by 4, which is 0. So therefore, the first three terms, they are, in this sequence, the first three terms, they are minus 1 by 2, then minus 1 by 4, then 0, right? So this is your answer. Now let's move on to the second question here. The second question tells us that they are asking that we need to find the 20th term of the sequence where the nth term is defined like this. So we are given the nth term as an, which is n minus 1, 2 minus n, 3 plus n. In this nth term, because we are required to calculate a20, which is the 20th term, we will put n is equal to 20 in an. So when you substitute n is equal to 20 in an, you would have a20. So we have, in place of n, we are writing 20, right? So that we have 20 minus 1 in the first bracket, then 2 minus 20 in the second bracket, and 3 plus 20 in the third bracket. So we can solve each of the brackets individually to have 19 in the first bracket, in the second bracket minus 18, and in the third bracket the value 23, right? So next we can multiply them to have our answer. So our answer is minus 7866. You can check your calculations here. Let's move on to our third question. In the third question, they are saying that if the sequence is defined as follows, where the nth term is given by n minus 1 plus 2 and the first term is given to be 1. So we need, for this sequence, we need to find the first 5 terms here. So let's solve this question. This is very easy. Here you are given a1, right? So obviously to find first 5 terms, they are asking, we are to calculate what is a1, we are to calculate what is a2, we are to calculate what is a3, right? We are to calculate what is a4, and we have to calculate what is a5. They are all missing, right? Now notice that a1 is given to you in the question. So we have a1 is equal to 1. So we are done with this part. Now moving forward for a2. We need to require a2. So what we do, for in the general term, we will substitute n is equal to 2 here. So when we substitute n is equal to 2 here, so an is equal to an minus 1 plus 2 here. When we put n is equal to 2, we have a2 is equal to a1 plus 2. So this becomes a1 plus 2, right? N minus 1 is 2 minus 1 is 1. So what is the value of a1? It is 1. So we have 1 plus 2. So that is 3, right? Similarly, when we have n is equal to 3, we have a3 is equal to a2 plus 2. Why this is so? Because here also in this case, we have an is equal to an minus 1 plus 2. When the value of n is 3, we have a3 is equal to a2 plus 2, right? And what is the value of a2? It is 3. So 3 plus 2, that is 5. So this is our third term. When next n is equal to 4, we have a4. a4 is a3 plus 2. Similarly, we will be putting this value of n is equal to 4 here in this expression. So we have a3 plus 2. What is the value of a3? It is 5. So we have 5 plus 2, that is 7. For the next term, we will substitute n is equal to 5. So we will substitute n is equal to 5, so that we have a5 is equal to a4 plus 2. So we have the value of a4 as 7 plus 2, which is 9. So therefore in this case we have all the 5 terms. So therefore the first 5 terms of the given sequence, the first 5 terms, they are 1, 3, 5, 7 and 9, right? So I hope you understood these questions well. Well, that is it for this video. Thank you for watching.